Hi, this is our research project, light detection. We using true light detection using sequences from video, create our deep learning RNN neural network. Our main goals are we use the mainly focus 3 steps. First of that, extract key points using Mediapipe Facemesh library. The Mediapipe is provided by Google. This is the Mediapipe official page, and Mediapipe has the lot of models. 30 to 40 billion parameters to train these models, and we use this Facemesh model. This Facemesh model has 468 key landmarks. This is that model, 468 landmarks in 3D. So we use this model for our extract key points from face, and then train the RNN LSTM model, and then make a prediction on real time. This is the contents of our notebook. We will go to the code and I will explain you. Line detection. This is our folder structure. This is a datasets folder. Dataset folder has the true and live folder. Every folder have the index and one video for the live videos, and same true videos. We have the live video 64 and true videos 159. And examples are some examples of images. Finally, we use true videos for real-time testing. We use datasets testing and training. Now we go to Python file. First of all, import all dependencies. Pip install one by one TensorFlow. We use TensorFlow and TensorFlow EPU for GPU purpose, and OpenCV, Open Computer Vision Library, and Mediapipe. I also say the Mediapipe library by Google, and sklearn4 model. Import 6 libraries. CV2 means OpenCV, and NumPy means our array files. We handle 2 array files for NumPy, and operating system for OS, and Matplotlib for visualizing a little bit easier for images, and Mediapipe and Math library for some mathematical functions. Then using Mediapipe declaration, Mediapipe is equal to mediapipe.solution.facemesh. We use the Facemesh library for 478 key points, landmarks, and also drawing styles and drawing. This Mediapipe detection function is do. We give the image and model. Image means using OpenCV to convert the videos to image, like in frames. Every images we will send the every images, not a video, images through the video, and give the Facemesh model. It will be return the same image, and results mean our Mediapipe processing output. Our model process output, that means result. So we give the media detection, we get the results, and this is the that Mediapipe 478 points example. This is the example points. This is the every points, like that. This face have the 478 points. Eye and iris and mouth. Also that Facemesh have the points. We will declare the face over points and left eye and right eye for blinking rate function. This is the blinking ratio function using gradient distance. This concept is we identify this point and this point, each same this way points, and we divide x into x divided by y. We get the ratio, eye ratio. So that's concept to use this blinking ratio function. We will give the some image and landmarks and left eye and right eye landmarks. It will be returned our blinking ratio, and then extract landmarks function. We will give the image and result. That result have the face landmarks in landmarks. We will set the whole landmarks in face, and same we get the ratio, and we return face and ratio. Face 478 points, 478 into 3, 1434, and ratio is 1 point, so 1435 points, 35 values. And we set up the folder for collection. Means this is the folder structure, datasets, and a Python file. We have the dataset for video files. Every dataset have the video files. Totally 63 live videos and 155 true videos. We need now trained. We need now one folder called ML data. Our action have the true and lie. Our true videos 156 and live video 64. Our sequence length means every video have the 30 frames, 30 images. This is the create a folder make directory function. If I run this code and then create the ML data folder, and go to each folder have the empty folders, not a data, empty folders, and then we will save the key points extraction values from this folder. collect the key points for testing and training. We use the each actions loop, and then we get the video path for that each part, and give the face mesh library, use the face mesh library, and get the and read the video to image using OpenCV. This is the OpenCV CV to video capture we will read, and cap.read function is giving the frame, and it means result return value, boolean value. And we will get the give the Mediapipe detection function, get the results and images, and give the images, image and results for extract landmark function, get the feature values. That feature values going to be served. NP path means that we created our folders. np.save each feature values. This is going to be true, and else going to be live section. All videos, live video 63 and true videos 155. Then because of labels and features, we import text and train and test function using evaluation metrics from sklearn model selection, and then categorical converting data for using TensorFlow character details. This is our label map declaration, like to have 0 and lies as 1. This is sequences and labels called features and labels. X data and Y data sequences. X data means sequences and Y data means labels. We get this each numpy folder, served folder, this folder, this file. Each file have 30 frames starting 0, numpy files. Every folder have this array folders. So this is our real data sets. This is the video data sets. This is our real time or training data sets, training and testing data sets in our data. Now we execute this function, and then we declare the x values to sequences and y values to labels, and testing and training part, x train, y train, and x test, y test using test and split function. This is our shape. X shape have the 220 means 220 videos. Each videos have 30 frames and 1435. It means key points into 478 into 3, 1434 points. Plus 1 is a ratio, or blinking ratio value. Totally 1435 values. And same Y shape 220 videos, 2 labels. Training shape divided by 0.5, 209 and 11, total 220. Fine. Our sequences finished. Now trainer build a LSTM tool using sequential layer and LSTM layer, dense layer, and TensorBoard, showing logs files for TensorBoard. And this is TensorBoard declaration. We use sequential model, LSTM, and then LSTM64. This is our input shape, X shape, 30 frames, and 1435 point values. This is the 2D shape, and using 3 LSTM layers, and finally activations of using softmax. Compile. Now I will give the 130 box to fit my model. With 100 feet, I will push my video. The model is incomplete. Frequency is 0.7 and loss function is 0.5. 130 box. Model summary is using 6 layers. Total parameters is 5 lakhs 30,530. Trainer parameters is that, and going to be prediction. X shape is our X testing shape, that 1435 points, 30 frames, and 11 to test split, and same Y test. We will save our model, and then our load model, and going to be confusion matrix accuracy. We will give the X test value to model to predict. Now I draw values this one, okay. Accuracy score is 0.72. Now going to be testing real time. This is the color. This is the output CVT text function, percentage and actions to print this on the screen. Use the testing main video, real time testing main video to using OpenCV video capture. This is the result. Model.predict. We give the sequences as 0. This is our output video. If we give the video our trained model will give the true percentage and lie percentage. We will check one more video for name. We will use only videos, not audio. We will not define any audio for this our model. We will give only the face and face total movements using 9 movements.